modern way to lay very solid foundation for educational career. Watch the subject of your choice several times to print the contents into your brain for stress-free examination success.
My name Untitled Johnson, your usual chemistry teacher, and like in all my teaching, I used to say, anytime you have question that bothers your mind, always feel free to send through this email number and WhatsApp number or my direct number on the screen. Yes, chemistry, the aspect of organic is what we are continuing with now. Told you about the alkanols. During my teaching of alkanols, I've told you the functional group of alkanols, the whole functional group, and some of the members. ROS stands for CH2N, our radical. Yes, I take ethanol as a case study in that teaching. And I said, by formula C2H5OH, that this ethanol, I said it is miscible with water, one of the physical property of ethanol. I want to review it, physical property of ethanol, that it is miscible with water. It is miscible with water in all proportions. Miscible with water in all proportions. Water soluble, high solubility in all proportions. It boils at 78 degrees centigrade. At 78 degrees centigrade, it has a characteristic smell. A characteristic smell. Ethanol smell. I said, it is neutral to litmus paper. Neutral to litmus paper. I've said it in my teaching. Yes. The chemical property of ethanols now. In one of my teaching, I've explained reduction, oxidation property. One is oxidation, and I've explained oxidation. I said primary alkanols. I said oxidizes to alkana. And alkana and the aldehyde oxidizes to alkanoic acid. To alkanoic acid. I said secondary alkanols. I said it oxidizes to alkanone, the so-called ketone. And finally, ketone oxidizes to alkanoic. Said it. And I've given example. After oxidation, we want to talk about another property of alkanols. Another property of alkanols. Another chemical property. Number 2, reaction with menters. Reaction with menters. Sodium hydroxide, potassium. When ethanol reacts with mentor, such as sodium menters, what you get is sodium ethoxide, and with the liberation of hydrogen gas. This one is a white liquid solution. Sodium ethoxide. Sodium ethoxide. The same thing applicable to potassium. They also give us potassium ethoxide. Note, hydrogen gas is liberated. And one of the tests for hydrogen is that it gives a pop sound. Take note of that property. Another chemical property of ethanols. I'll talk about the reaction with alkanoic. To form ester. So I call it esterification reaction. It's one of the chemical property. Esterification reaction. So another chemical property of alkanols. So alkanols react with alkanoic. Alkanol react with alkanoic in the presence of dilute acid. It react with alkanol. This ethanol react with ethanoic. Catalyzed by with dilute acid. My H plus coming from the acid, H also 4. The alkanol donate OH, the acid donate hydrogen to give us CH3, CO, CH3 with water. The reaction is a reversible reaction catalyzed by acid. So by name I have explained in one of my lectures. This is methyl ethanoate. This is methyl ethanoate. I said this is methyl. I've explained why this one is methyl on my lecture, and that this methanoate, it is not meta, because this is ethanoic acid. When you lose hydrogen, it becomes methanoate ion. This is methanoate ion. Methanoate ion. So same thing. When CH3COOH, when this one loses hydrogen, it becomes ethanoate ion. So this one will be called methyl ethanoate. Students, don't confuse again. I keep repeating. Methanoic acid, ethanoic acid. When you see C2, don't. When you see C3. So each time you see HCO2, that is methanoic, ethanoic, propanoic, butanoic. Don't pronounce your CH3 as meta, but ether. Methyl ethanoate. Take note. Take note of our explanation. Another chemical property of alkanols is their dehydration reaction. Their dehydration. Let's talk about the combustion reaction. The combustion reaction. Because they undergo combustion reaction. They undergo combustion reaction. Unlike our hydrocarbon to liberate carbon dioxide and steam. All hydrocarbon, alkane, and alkyne, they under combustion, when they react with oxygen, they liberate carbon dioxide and steam. So is our ethanol, C2H5, OH plus O2. Also give us CO2 plus H2O, steam, gas. So take notes. Balance the equation as usual. As usual. Balance our equation. You balance our equation. You balance it. Oxygen. How many of oxygen do you have? 2 here. CH2. This is 2 CO2. 2 C2. Leave your 2 here. How many oxygen do you have here? 2 here. 2 C. Yes. 2 C. Balance it. 3 oxygen. Our oxygen will be 3. That will be 3. 6. Our carbon is. How many carbon do we have? Let's balance it so that you know how to balance this equation. When we balance, I want to balance this chemical equation. This is my ethanol, C2H5 OH plus O2. The product is CO2 and steam. I want to balance the hydrogen first. 5 hydrogen here, 2 hydrogen here. I put my 2 here to make 10. Here will be 5 to make 10. Hydrogen is balanced. Carbon is 4 here. Put 2 here to balance carbon. Now oxygen. Oxygen is 4 here plus 5 here. That is 9. Oxygen here is 2 here. I need another molecule of oxygen. I need 2 plus 7. This is 7 over 2. This is 7 over 2 here to balance. That's a balanced equation. Number 5. Ethanols. Another reaction of ethanol. I've talked of oxidation. I've talked of reaction with metals. The acidic properties. Let's talk about the dehydration reaction. The dehydration reaction of ethanols or alkanols. Ethanols. Using conc H2SO4. C2H5OH. When dehydrate, you have your ethene with your water molecule. Water will be removed. Water molecule. Ethene with your water. So using conc H2SO4. So with conc H2SO4, ethanol dehydrates to produce ethene. Take note, students. Another reaction, I've given you 5 points, is the reaction with pentachloride. Reaction with pentachloride. Our C2H5 OH plus our pentachloride to give us POCl3 plus C2H5 Cl. Look at that equation. Balance, check. O3 plus our ACl. Everything, P here is balanced, chloride here is 5, 3 here, 1 here, 1 here, correct. Hydrogen is 5 plus 1, 6. This hydrogen here, 5 plus 1, 6. That is a balanced equation. So, our product here is potassium monoxide plus chloroethane. This is ethanol. This potassium trichloride. Oxychloride, this is chloroethane. Take note. The ethane itself is C2H5, A6. So if there's a displacement reaction of chloride, it becomes chloroethane. So these are the chemical property of ethanols. Chemical property of ethanols. Now, let's look at the preparation of ethanol. Preparation. Ethanol can be prepared in the laboratory. We have laboratory preparation, as well as industrial preparation. Industrial preparation. In the laboratory, in our laboratory preparation, I want to talk about hydration of ethene. We are adding water molecule to ethene to get ethanol. Hydrolysis of iodoethane. Laboratory preparation. So if in the laboratory I want to explain hydration of ethene. Hydration of ethene. If ethene is hydrated with water, what you get is C2H5OH. This is our ethene. This is our water. This is our ethanol. It produces ethanol. If you have your iodoethane hydrolysis of iodoethane C2 to give us C2H5OH plus NaI. If you look at this equation, if you do the hydrolysis, I'm using sodium hydroxide to hydrolyze my iodoethane. I said C2H6 is ethane. When you displace with iodine, it will be C2H5. I now call it iodoethane to also give us ethanol. Let's look at the industrial preparation, which is very common in your WAEC and JAM question. Industrial preparation in the industry. I will talk of preparation by fermentation, fermentation process. By fermentation process, I will discuss production of ethanol from starchy food, from starchy food. Our potatoes, sweet potatoes, our wheat, our barley, our starchy food generally, potatoes, wheat, and so on. From palm wine, from our palm wine. We also talk about, we can also prepare ethanol from our cellulose. But majorly, the common in the industry, the commonest process is that fermentation. There are a lot of sources through which you can prepare your ethanol. Some use starting from brewery process. So let me explain this fermentation so far. I want to explain fermentation. Fermentation, I call it, it is the slow decomposition. Decomposition of large organic molecule into a small molecule using an enzyme. The enzyme will start of your catalyst. That is fermentation. So in the industry, by fermentation, I want to explain preparation from starchy food as a case study. Preparation from starchy food as a case study. So in the industry, if you are preparing from a starchy food, preparation from, I want to use potatoes as a case study. The first stage is in our stage 1. In our stage 1, it will be crushed. The crushing of the material after peel, crushing of the material to extract the juice, the molasses. So we now treat the starchy liquid obtained, treat the starchy liquid with an enzyme. The enzyme, we call it diastase, which converts the starch to maltose. The starch will be converted to maltose. This is what I mean. The diastase contain malt. Malt is a partially germinated enzyme. At about 55 degrees centigrade. The starchy food will be converted to diastase. You are converting the starch to diastase. This is our starch, 6H10O5N. Diastase, like I said, diastase will contain malt at this temperature. It will change this starch to maltose. Maltose is a solution. Remember I said from starch to maltose. Maltose is a solution. If you are going, another stage, I call it stage 3. This is stage 2. In our stage 3, the maltose will be converted to 2 molecules of monosaccharides. We call it disaccharides. And the enzyme I will use will be maltase. Don't forget, as I list, starch to maltose. Diastase converts starch to maltose. Maltase converts the maltose to 2 molecules of monosaccharides, C6H12O6, C6H12 O6 is an hydrolyzing enzyme. Hydrolyzing, water molecule must be present. And the last stage will be that the simple sugar molecule, the glucose solution, will be converted to ethanol and carbon dioxide. That is an ethanol. So the last stage will be the glucose will be converted by the enzyme zymase to 2C2H5OH, which is our ethanol, plus 2 molecules of carbon dioxide gas. This is our liquid. This is the ethanol. You see, the ethanol here may not be 100% pure. It depends on what is to be converted to. Some will be converted to beer, depending on the liquid needed. But in most cases, to obtain an ethanol that is pure, there is need to treat it with by fractional distillation. Take note, students. By fractional distillation, using quicklime. Our quicklime is calcium oxide. Maybe about 72 hours to get an ethanol that is 95% pure. That's the stage in fermentation process involved in converting ethanol, in converting starch to ethanol.